So for question 13, it says explain how the zeros in multiplicity are connected. Sketch one example, elaborate using one example. So I'm going to be showing you how zeros and multiplicity are connected. So let's first start by writing out what we're looking for, zeros and multiplicity. So we already know what the zeros are, but something you probably haven't heard of is multiplicity. And what that simply means how much it appears in the equation. So you're probably wondering, how much does what appear? But it's not really complicated once you get the idea of it. So for now, just keep in mind the multiplicity is how much it appears in the equation. So let's say we have an equation that is f of x equals negative 2 x minus 4 cube x plus 6 and 3x minus 5. Okay, so we have this equation, right? What you're gonna notice is that negative 2 in this case doesn't really matter, because when we're talking about the zeros, we're talking about something that has to go with an x, right? Well, negative 2 doesn't, so we can just really ignore it. It's not really gonna cause anything for this problem because it doesn't come with an x. It's not a zero. So the first thing we're gonna do to make this a lot easier, we're going to solve for the zeros by using the factor we already have. So let's get started. To solve for 0, we set them equal to 0. So let's set x minus 4 equal to 0 first, right? Well, we add the 4 to solve it, right? And we get that x equals positive 4. That's our first 0. If we have x plus 6 set equal to 0, well, we see that we have to take away the 6. So we get that x equals negative 6. If we have 3x minus 5 set equal to 0, well, we have to get x by itself. So in order to do that, we add the 5. So that would be 3x equals 5. And to get rid of this 3, we divide by 3. We divide by 3, so we get that x equals 5 over 3. So now that we have our zeros, we can see what the multiplicity will be. We know that when we're talking about x equals 4, it's the same thing as x minus 4, right? And that x equals negative 6 is the same thing as x plus 6. And that x equals 5 over 3 is the same thing as 3x minus 5, right? We know that for sure. So let's look at this. We have an exponent right here. And we know that this exponent means that x minus 4 is exactly the same thing as x minus 4, x minus 4. Right? We know that for sure. Because this is saying that there's 3 of those. There's 3 as many times. So that means that this has a multiplicity of 3. It has a multiplicity of 3 because it appears 3 times in the equation. X minus 6 or x plus 6 has a multiplicity of 1 because it only appears once in the equation. And we know that 5 over 3 has a multiplicity of 1 because it only appears once in the equation. But if we were to have, say for example, a squared root right here, then this would have had a multiplicity of 2 because that means that it would have appeared 2 times in the equation. So that is basically what the multiplicity means. It's just how much they appear in the equation, and they relate to the 0 because in order for you to find the multiplicity, you find the zeros, right? So say we have a graph, right? Say we have a graph. And our equation is f of x is x minus 3 squared. Well, if we set that equal to 0, we get 0 equals x minus 3, and we get 0 equals 3, right? Okay. We get our 0. Our 0 is 3. So now we graph this. And what this simply means is that it's going to graph at 3. It's going to graph at 3, and it's going to bounce. It's going to bounce off. Like when it's coming down, it bounces up. So because of that squared, we have a multiplicity of 2 because it comes down but it bounces up, so it's like 1, 2 because it bounces because of the squared root. And that's what that means when we have multiplicity. So once again, multiplicity is just simply how much it appears in the equation. That's what multiplicity means. And it relates to the 0 because when you have a function, an equation given, you have to solve for the zeros. So anything that comes paired with an x, you set that equal to 0, like so. and you solve for 0. You solve for x, right? So for the first one, we got that x equals 4, since it was x minus 4 equals 0. For the second one, we got that x equals negative 6, since it was plus 6, so we took away 6. For the third 0, we got that it's 5 over 3, because we have 3x minus 5 equals 0. We added the 5, and then we divided by 3. And we saw that with the exponents, x4, or same as x minus 4, appeared 3 times. So it had a multiplicity of 3, because that's how much it appeared in the equation. For x minus 6, originally it was just there once, so it had a multiplicity of 1. Same thing for x equals 5 over 3. It appears once, so it has a multiplicity of 1. And then I went ahead and wrote an example and put a square root over x plus 6. That would have made it a multiplicity of 2, because it would have appeared 2 times. So once again, the exponents are what tell you how many times it appears, and that tells you what the multiplicity of that 0 is. And remember, to find the 0, you get your given equation and set that equal to 0. As for the graph part, it's exactly the same thing. You have your little function and you set it equal to 0, and then you solve for your x. And once you graph it, we notice that here it bounced. It came down 1. When it reached 3, it bounced up 2, because of the squared root, which made it have a multiplicity of 2, which made it have 2 going up, or a bounce. This is something that we call a bounce. So this is for the zeros and multiplicity and how they are related.